Today we kind of did an intro to statistics with some vocabulary and looking at some tables and defining variables and things like that. Today we're going to talk more about the statistical study process. So consider the following claims. After a good workout, it takes 5 hours for the body to return to its normal temperature. Being a statistician is a better job than being a doctor or lawyer. The average IQ of females is 8 points higher than that of males. And it's impossible to eat 6 saltine crackers in 1 minute without licking your lips. So how might you prove or disprove these claims? And the catch is that, well, not a catch, but statistical studies is one way to investigate such claims. And so at the end of this third quarter, beginning of the fourth quarter, you guys are going to be actually doing a statistical study. So as we go through here, we'll talk about what's called a research question, which you'll probably want to start kind of considering and thinking about now as we go through this stuff. But it's going to be, I don't know exactly when the time is, but it's going to be after the statistics unit at the very end, which goes through the third quarter, maybe the beginning, the very first unit of the fourth quarter. So the statistical study process always is going to start with a research question. And the research question is just something that you want to know in simplest terms and anticipates using some type of data that varies across the population. So we have more vocabulary words here. Once you have a research question, we'll talk about how to write one later on. But then you want to determine your population of interest. So a population is a group of people, animals, or things. So if you're trying to do something, if you're interested in something about Rottweilers, like your population of interest is going to be Rottweilers. It's not going to be people. It's not going to be anything like that. So a census is when data is collected from every individual in the population, but it's usually not very practical to conduct a census. Therefore, we collect what's called a sample that represents our population of interest. Once we gather that information, we organize, summarize, and analyze the collected data to learn about their general features. So, within the statistical studies process, there's 3 different types of statistical studies that we're going to talk about, and one of these 3 is something that you can do. The first one is called an observational study, and it involves observing and recording data on some type of variable of interest, attempting to leave the sample undisturbed. The other type is a sample survey. That uses questioning to gather data, attempting to leave the sample undisturbed. In other words, you don't want to influence the person or whoever's doing the survey. And then we also have an experimental study, which manipulates all or part of the sample in which data of some variable of interest is being taken. So we're going to look at some examples of these. I don't know why that automatically popped up, but just kind of looking at some scenarios and determining whether or not these studies were observational, sample, or experimental, so we can kind of get an idea on what those might look like. So suppose on cold days you record which of your classmates come to school without a jacket. Later you record how many of those students become sick. So did we influence or the word I used, manipulate anything here? No, all we did was we just watched. We looked at which kids came to school with and without a jacket, and then we recorded how many of them became sick. So what would that be? That would be an observational study. You have a sample of doctors complete a questionnaire about health risk involved with going out in the cold without a jacket. Questionnaires are a key word here. We're asking a question. That is going to be a sample survey. You find 30 adults and divide them into 2 groups. The first group is told not to wear jackets on cold days. The other is told to wear jackets on cold days. You then compare the number from each group who gets sick after a string of cold days. Now here you did influence. You actually manipulated or you controlled something in here. Who wore the jackets, who did not. So that would be an experiment. Students are asked what their favorite class is. You're asking a question. That's going to be sample survey. A study observed student attendance rates and compared them to student grade data. Nothing's being manipulated or controlled here. We're simply observing attendance rates and comparing them to student data. We're not asking a question. This is going to be observational. A student takes, excuse me. A study takes one group of students who ride the bus and one group of students who drive cars and monitor their tardy rates. So we're not controlling anything here or influencing or manipulating. We're simply taking one group who ride the bus and one who doesn't, and just observing. Who rides the bus? What time do you get here? Are they tardy? Who doesn't ride the bus, and recording their tardy rates. This would just be observational as well. Okay, so we're going to break down kind of the observational study first. We're going to look at each one of these studies. An observational study, it's important that we define our variables that we're measuring, identify the sample and the population you are observing, and determine how you will collect the data. After collecting and analyzing data in an observational study, the findings in the sample are used to draw conclusions about the population. So here we have an example where we want to determine the variables, samples, and population in the following observational study in order to see whether males and females differ in the amount of time they spend in a grocery store. You stand outside the supermarket and record the time when every 10th person enters the store and the time when that same person exits. So what are some of the possible variables here? What are the samples and what are the populations? Well, our variables can be things like gender, right? We're trying to find out whether male and females differ. So males and females, that's what we're kind of concerned with. And then also the other one is the time they spend in the store. So categorical, that would be categorical variable. This would be quantitative. Your sample are going to be simply the people that you record. Now, once again, the population is going to be like all males and females. But you happen to, maybe you just go to one store, maybe you go to multiple stores. Either way, you collect a sample. This sample is the actual people that you're gathering data from, that you're observing. The population is going to be all people going in and out of the store. It's important to note that this sample is not a representative of the population of all males and females. So, in an observational study, not all observationals involve actually physically observing something or someone. We're going to take a look at an example real quick. So consider this graph. This represents the percentage of males and females over 18 years of age who shopped online during a 30-day period. This data was actually collected more than likely by online cookies. Some of you guys probably are familiar with what that is or have at least heard that terminology. But this isn't actually involving physically observing something. This is where internet sites can assign a cookie to each visitor. This cookie includes a name-value pair that records the user's data. And that data may include the time of the visit, the number of visits to the site, and the ads the visitor clicked on. Those would be all the types of variables. Until the user deletes the cookies, the site will accumulate information with each visit. The site can then use this data to advertise directly to your interest. So that would be observational without actually observing physically with eyeballs. Designing a survey. So here is where your survey attempts to measure samples without disturbing the samples by asking questions of a population and recording your data. So questions would need to be written in a way that will not influence the population. Survey questions are not your research question. So we'll look at an example here in a second, kind of showing that. The number of questions being asked is not important, but the quality of questions are. Beware of response bias, which we'll talk about next week. Make sure your questions are worded in a way to get authentic answers. And remember to stay open to any results while writing your survey. You are not using your survey to prove something you already believe. So let's take a look at a kind of a famous survey by a man named Hadley Cantrell, who started this. In the mid-20th century, a public opinion researcher named Hadley Cantrell was interested in how to measure happiness. So when you're coming up with a research question, you start here, like what's something that interests you? He was interested in how to measure happiness. He designed a 2-question survey known as the Cantrell Self-Anchoring Striving Scale in 1965. So picture a ladder with rungs numbered 0 through 10, where the bottom 0 is the worst life you can imagine, and 10 is at the top and the best life you can imagine for yourself. So something like this. So at the top, we're thriving, in the middle, we're struggling, and at the bottom, we're considered suffering. So the 2-question survey was simply, on which step of the ladder do you feel you are standing at this time? Not something like, are you happy? Are you sad? It's like, where do you feel you're standing? On which step do you think you'll be standing in 5 years? After testing and refining the survey on a large number of respondents, here's how Cantrell scored answers. I don't know how he came up with this, but this is what he came up with. If you scored at least a 7 on the first question and at least an 8 on the second question, you are thriving, you have a positive sense of well-being. People in this category worry less, have less stress, fewer health problems, and are generally happy. I think most of the time, if you think about that, like let's just say you feel like you're doing well, so you would be at a 7. You're probably a little more optimistic, so you would hope in 5 years that you would be at least where you're at, or hopefully in a better place. If you're kind of being a pessimist, or maybe you complain a lot, you just think that everything's getting worse. So you may feel like a 5 or a 4, and then you just surely think in 5 years it's going to definitely be worse. So who knows? I don't know how he came up with this, but that's just my interpretation of, like, I don't know, the ways people think depending on their positive outlook on life. He said that if you scored a 4 or below on both questions, you are considered suffering. Your well-being is at high risk, and your future outlook is depressing. People in this category are twice as likely as thriving respondents to suffer from disease, stress, and a lack of basic necessities. And then finally, if your answers did not place you in one of the first 2 categories, you are struggling. Your well-being is moderate and unstable. People in this category tend to eat less healthy, report more daily stress, and take more than twice as many sick days as those who are thriving. So the same type of survey was used to measure the suffering around the world. And in a recent survey of countries, Denmark had the lowest percentage of suffering at 1%. Zimbabwe had the highest at 40%, and the United States was around 5%. So we're not going to do this really in class, but I'm going to give you some time to do this, but I'm not really going to go over a whole lot of this. But I want you to just, we're going to take about 3 minutes and answer these questions. How accurately do you think Cantrell's survey measured happiness? What are some problems with using the survey to measure happiness and suffering? And how would you design a study to measure happiness? In class, I would give you all 3 minutes, and then I would ask some people to kind of share out their thoughts. So statistics is not like it's kind of a step to follow, but a lot of it is like analyzing things and interpreting stuff. So it's important to try to write these things down to get your brain practicing thinking like this, like a statistician. Okay, so we looked at designing an observation and a sample survey. Now we're going to look at designing an experiment. So the researcher will manipulate the sample to provide answers to specific questions. Sorry, I had to pause my video. So with designing an experiment, the researcher will manipulate the sample to provide answers to specific questions, and then determine a sample population in a non-biased way, which we'll talk about bias next week. Something is manipulated to retrieve the So the example we're going to look at is called the Hawthorne effect, and I'm actually not going to show that in class, but I have a video, or I'm not going to show that on this video. So if you want to look it up, you can. But we'll talk about it nonetheless. In the late 1920s, an experiment was conducted on workers in an electric company named Hawthorne Works. Before informing workers about the experiment, researchers secretly observed their productivity for 2 weeks. And researchers then increased the brightness of the lights in the factory and observed the workers' productivity levels. For a short time, productivity increased. Productivity also increased when changing the amount of break time, providing food during breaks, and shortening the workday. So yes, the researchers observed, but they did this in an experimental way. They were manipulating things here. They were changing the brightness, things like that. So here we have this Hawthorne experiment video that if you want to watch, you can. I'm not going to show it here. But once again, in class, I would show that video, and then I would have you guys talk with your groups and then share this stuff out. So what factors do you think could have caused the increase in productivity? The workers knew that they were being observed, so they worked harder. Think about that. These are the types of things we're looking at. The lights really did increase productivity, or maybe there was increased peer pressure. How can you improve the design of such an experiment? Increase the brightness of lights without informing workers of the experiment might be one way. Informing workers but splitting them into 2 groups. And then the conclusion of the Hawthorne study is research subjects may change their behavior because they know they are being observed. In this case, researchers concluded that workers felt they were being judged for their individual performances. This is now known as the Hawthorne effect. So that is an experiment. And then we have this last one that we're going to look at here, where I'm going to have you guys see if you can identify any flaws in this experimental design. So what weakness can you identify in the following design? Suppose scientists were interested in whether a medicine called Revenol would lower blood pressure. By advertising in the newspaper, they got 120 participants. The scientists used a random number generator to split the 120 people into 2 groups, a control group of 40 people and an experimental group of 80 people. They then separated the experimental group into a low blood pressure group and a high blood pressure group, each with 40 people. They gave the experimental groups a daily dose of 100 milligrams of Revenol. Each day, they also gave the control group a placebo, which is a false treatment such as a water pill used to prevent participants from knowing whether they are in the treatment or in the control group. After 1 month, the scientists found that the low blood pressure group had significantly lower blood pressure than the control group. They declared Revenol a success. So group discussion. What do we have? So what flaws did we notice, if any, from this experiment? This was an actual experiment that was done. So think about that. The assignment into the first 2 groups was random, but the sampling wasn't. So, however, the main problem is that the experimental groups were divided according to the same variable that was being tested, which is the blood pressure, making the results meaningless. This question is based on an actual medical study. So that's just kind of a little bit of a breakdown, introducing those different types of studies for you. I'm going to ask you what type of study, observational, experimental, or survey, like what type of thing is that? What type of study is this? But I'm not going to go into specific things as far as like that last problem. But it is important to kind of consider as we start getting further and further to the statistical study to get our minds right so we can kind of think like a mathematician. So your delta math has 1, 2, 3, 4, 5, 6. So the next 6 problems in your delta math, the previous one should already be complete at this time. These 6 are asking you the types of statistical studies.